Welcome back to the deep dive. Today we are shortcutting you straight past all the dependency hell.
All the build configuration nightmares.
Exactly. We're getting away from all the linking struggles that, plague so much of C and C++ development. We are diving deep into the CBRB collection.
A set of single-file libraries that are, well, they're more than just code. They're a whole philosophy of software distribution.
Okay, let's unpack this. Because the STB libraries, which were created mostly by Sean T. Barrett, they're not just a handful of little utilities.
No, not at all.
They've really changed how a lot of developers think, especially in, games, graphics, high-performance stuff. They've changed how you integrate things like image loading or font rendering.
And our source for this is basically the GitHub repository's readme file. But it's less of a readme and more of a manifesto for this whole style.
Right.
It details, over 20 different libraries? So our mission here is to really dissect the genius of this single-file header approach and, crucially, understand the trade-offs that come with it.
And the scale is the first thing that just grabs you. I mean, we're not talking about a small utility build.
No.
The source lists 21 libraries. It adds up to 51,137 lines of C code, all of it distributed in this really unique, super minimal format.
Now, the license is just as simple. It's public domain.
Which means you can do literally anything with it. But there's a catch there, right?
Well, a helpful one. It's public domain or the MIT license, and that dual license thing is really smart.
Right, both.
Because public domain, as great as it sounds, can be legally murky in some countries. Some corporate legal teams just get nervous about it.
So the MIT license is for them.
Exactly. It gives them a clear, universally recognized legal framework. The whole point is zero barrier to adoption. Not just technically, but legally too.
So the barrier is zero, but how do they actually do it? How do you package 50,000 lines of complex C code into something so simple?
It's all about one little trick.
The magic macro.
The magic macro. By default, you just include std.image.h, and it acts like a normal header file. It's just declarations.
Right, just function prototypes.
But then, in exactly one of your C or C++ files, you add one line before the include.
Something like #define ST-BImage implementation.
And that's the switch. That tells the compiler, okay, this time I want all the code, inject the entire implementation right here.
If we connect this to the bigger picture, that's your line, isn't it?
Yes. If we connect this to the bigger picture, the real driver for this was solving pain points on Windows.
Oh, interesting.
Yeah, I mean, if you're on Linux or Mac OS, you kind of take standard library locations and build systems for granted. On Windows, historically, it's been a mess.
Right. No uslocallib or anything like that.
And worse, you get these horrible runtime library conflicts. Your project is built with Visual Studio 2019, but the library you're trying to link was built with 2015.
Ugh, the MSVC redistributable nightmare. I've been there. It's awful.
It's a debugging nightmare. But this approach just sidesteps it completely.
Because you're compiling the library's source code directly into your own project with your compiler, your settings.
The conflicts just vanish. It's a beautifully elegant hack. It completely removes the need for precompiled binaries or managing shared object files.
You just drop the file in your project and compile. That's it.
It's the ultimate dependency control.
And the creator's so insistent on this, not 2 files, which is, standard practice, 1 file. He says, the difference between 10 files and 9 files is not a big deal, but the difference between 2 files and 1 file is a big deal.
And it's true. It's a psychological win. You can't forget the implementation file. You just grab the header and you're done.
So the whole product they're selling here isn't features, it's simplicity. It's deployment purity.
Minimum mental overhead. Define 1 macro, include 1 file, done.
So the principle is solid. But what do you actually get in these files? What's the scope here?
Well, the flagship is probably spimage.h.
That's the one everyone knows. It's nearly 8,000 lines of code just for loading images. JPG, PNG, GIF, even HDR files.
Yeah, that's functionality that you normally need massive, complex libraries for, like libjpeg, libpng.
Total pain to set up.
And then there are things that are pure C infrastructure, like stbds.h.
Oh yeah, talk about that one.
For C programmers, this is huge. It gives you typesafe dynamic arrays and hash tables, basically data structures that C++ people get for free with the STL.
Right. In C, you're usually rolling your own or using some clunky external system.
And here, you just get these powerful containers compiled right into your code, no dependencies. It's so valuable for people working on older pure C code bases.
We should also mention it's not all Sean Barrett's work. It's become a sort of community standard.
For sure. You've got SPBDXT, which is a texture compressor by Fabian Giesen, Rig, he's a legend, and other utilities by Jeff Roberts. The single file idea has really caught on.
Which brings us to the big question, the one that ReADME asks itself.
Yeah.
Are these libraries actually better than the alternatives?
And the answer is, it's nuanced.
It's a trade-off.
It's a huge trade-off. The source is very clear. They are better because they are easier to integrate, easier to use, and easier to release.
But they might be slower, less feature complete, or use more memory.
Exactly. So you have to make a choice. If you're building, say, the next Photoshop, you need every last drop of performance from your JPEG decoder. You'll deal with the headache of linking libjpeg.
But if you're a hobbyist game dev, or you're just shipping an internal tool,
the simplicity of dropping in Spimage is absolutely worth a slightly slower load time. You're trading peak performance for maximum deployability.
I also found it really interesting that they use lines of code, low C, as a metric. I mean, everyone knows that's a terrible metric for software quality.
Right. But the reason they give is actually pretty good.
What's the logic?
They say it's just to give you some idea of the internal complexity of the library. It's expectation management. You see 400 lines for a noise generator versus, 8,000 for image loading, and you get a feel for the code mass you're about to import.
That's surprisingly honest. And that count includes everything, right?
Mm-hmm.
The header, the implementation, and the documentation.
All of it.
Okay, we have to shift to something more serious now. There's a big security warning right at the top of the readme.
And this is critical. Because these libraries are so popular now, they're a big target.
What's the warning?
They state that security bugs are discussed publicly on GitHub, but, and this is the key part, the merging of fixes may take significant time.
Oof. So if you're building something that handles untrusted files from the internet,
you're taking on what they call an unreasonable risk. You, the user, have to actively monitor the public issue tracker. It's not like getting a patch from Microsoft on a Tuesday.
And we can see the impact of this on Stupanage.h. They've basically frozen its features.
Yeah, they state they will not be adding new image formats.
Why?
Because every new format increases the amount of code we need to secure. They've made a choice. Stability and security over new features.
That feels like a very mature decision for a project to make.
It absolutely is. It's protecting the millions of people already using it.
Shifting gears a bit, let's talk about the language choice.
Yeah.
It's all C, primarily.
Right. And the creator gives two reasons. The first is simple. He uses C.
Fair enough.
But the second reason is, again, all about simplicity and adoption. Writing them in pure C makes the foreign function interface, the FFI, super clean.
Which makes it easier for other languages to call into it. Python, Lua, Rust.
Exactly. It just broadens the potential user base massively.
And now, for my favorite part, the creator's personal workflow. The libraries avoid a lot of modern C features from C99, things like student.h or declaring variables wherever you want. Why?
Get ready for this.
I am.
He still uses Microsoft Visual C++ X from 1998 as his main IDE.
Wait, what? MSVC6 from 1998? Are you serious?
He says it has better human factors for him, and because that's his tool, he avoids language features it doesn't support.
That is wild. A personal preference from decades ago is setting the technical constraints for code used by millions of people today.
It's an incredible example of the human element in software, and it has real consequences. Without student.h, you can't be sure you're getting a 32-bit integer, so you have to do extra work. It's a sacrifice made for the creator's toolchain.
Unbelievable. Okay, one last technical point.
Right?
7D. So things like SSE for optimization.
Right. And again, this comes back to the single file philosophy. The best way to do runtime detection, to check if a CPU supports SSE and then use the fast code path, usually requires multiple source files in a compiler like GCC.
Which, of course, violates the core principle of the whole project.
It's totally incompatible. So they made a choice.
Yeah.
Stivage either uses SSE2 if you compile your whole project with that flag enabled.
Or it uses no SIMD at all.
Exactly. The single file architecture won. That principle is the highest priority above even automated maximum optimization.
So after all that, what does this mean for you, for the developer listening?
I mean, the essential takeaway here is that SDB is a massively successful trade-off. It prioritizes ease of integration and simple deployment above everything else.
Especially for avoiding those Windows-specific headaches.
Absolutely. It's an elegant solution to administrative and legal overhead, and it's just, generously offered to the world.
And as we close out, I want you to think about how complex some of these single files get. The ReADME mentions stdablemapeditor.h, and spb voxel render.h.
Yeah, that's a full embeddable tile map editor.
And a Minecraft-esque voxel rendering engine. An entire engine in a single header file ready to go with one macro.
It's amazing.
So given that this deep dive shows how these incredibly complex systems, an editor, a rendering engine, can be bundled into one file with basically no dependencies, where do you draw the line? What really separates a modern huge code base from a hyper-focused single-file project? And where does the line between a utility and a full-blown application just completely blur? Something for you to chew on until next time.